Welcome to today's lesson on ordering fractions. Now we've talked about this just a little bit, but we're going to get more in detail and learn some other strategies. So today's goal, students will be able to order fractions by using estimations. We're going to use some benchmarks, 0, half, and 1, to decide kind of what it's closest to, and that'll help us order a lot of different types of fractions. Order fractions by using cross multiplication, and order fractions by making like denominators. We will be doing some more work in class also with some further activities, so this will hopefully be just a short review and introduction to this topic. All right, so one strategy is estimating by trying to figure out if the fraction is pretty close to 0, pretty close to a half, a little more than a half, a little less than a half, and then if it's pretty close to 1 whole. So if we look at these fractions right here, we can see this bar split into 11s. We're comparing 11s here. This right here would be 0. This, of course, would be 1 whole. And let's think right off the bat, what would half of 11 be? So how much would I shade if I wanted to do 1 half of 11? Well, you can tell right away that 11 is not an even number. Half of 10 would be 5, half of 12 would be 6. So right in between, half of 11 is going to be 5.5. So 1, 2, 3, 4, 5, and then half of this one. So this would be our halfway mark right here. All right, so let's take a look at these. We can see that 1/11 is really close to 0, which would be 0/11. Okay, 1 half would be, we said 5.5 11ths, and 1 whole would be 11 11ths. So 1/11 is right here, which is very close to 0. 2/11 is also pretty close to 0. 5/11 is very close to 5.5. 7/11 is also very close to 5.5. So both of these we could say are close to half. Now, if I know that 5.5 is exactly half, then I know that 5/11 is going to be a little less than a half, and I know that 7/11 is just a little bit more than a half. And then also 9/11 and 10/11, if I know 11/11 is 1, then I know that both of these are pretty close to 1, just a little bit less. So you'll find that that's going to help us out later on when we want to compare some fractions. Let's say that one fraction I know is a little bit more than a half and the other is a little less than a half. I'll be able to determine which one is larger. All right, so let's take a look at these fractions and try to use that strategy that we just talked about. All right, so let's start with 3/4. What do I know? I know that half of fourths would be 2/4 and a whole would be 4/4. So 3/4 is going to go right in between 1 half and 1. So let's stick 3/4 right about here. All right, 1/10. Well, 0/10 would be 0 over here. 1/10 is going to be just a little bit more than 0. So we'll place that right about here. Now we're kind of estimating here, but that's okay. Let's take a look at 14/15. 15/15 would equal 1. So 14/15 is going to be just a little bit less than 1. Put that right here. 3/5. That one's a little bit trickier. If I take half of 5, that's going to be 2.5. So half would be 2.5 and 1 whole would be 5/5. Well, 3 is pretty close to that 2.5, but you know that 3 is just a little bit more than that. So again, just to illustrate, 2.5 would be exactly 1 half. 3 is just a little bit more. So let's put 3/5 as just slightly above that 1 half mark, but definitely below 3/4. And then 5/12, again, 6/12 would be exactly half. 5 is a little bit less than 6. So even though these two fractions are both really close to half, I know that this is a little bit more. 5/12 is going to be a little bit less. So I know that 5/12 is less than 3/5, even though they're both pretty close to half. So notice how I could order all of those fractions with different denominators just by thinking about if it was close to 0, pretty close to 1, halfway between half and 1, or a little bit more or less than a half. This really is an extremely useful strategy and really easy for some fractions. Now it's not going to work for all of them, but when it does, it's pretty slick. All right, so we've already done that set of numbers, so we're going to go ahead and go down to our T-chart here. Go ahead and pause the video. Then I would like you to copy these. We're going to do an example or two of each one. All right, so first of all was our estimation that we just talked about, and that's comparing to 0, half, or 1. So if I give you two fractions, let's try 3/7 and 5/8. And I want to know which one is larger. Well, 3/7, half of 7, it would be 3.5. So this is a little bit less than a half. And so we'll just write 3/7 is less than 1/2. 5/8, half of 8 would be 4. 4/8. 5 is a little bit more. So 5/8 is a little bit greater than 1/2. So if this is less than a half and this is greater than a half, then I know that this has to be my smaller number. So 3/7 is less than 5/8. All right, so making like denominators. Let's try that one. So let's say I have 3/8 and 2/4. Well, this one, and again, which strategy you pick is really going to depend on what your fractions are and which one is the easiest and works the best for those two fractions. So now this one I see that I can make like denominators fairly easily, whereas up here, 7ths and 8ths, that's not quite as simple to make like denominators. But because this one is, let's try this strategy. So I'm going to choose 8ths as my denominator. So 3/8 will stay 3/8. And then I'm going to change 2/4 to 8ths. So 4 times 2 is 8, and 2 times 2 is 4. So 2/4 is the same as 4/8. Well, now that I have same denominators, 3 pieces is less than 4 pieces. So 3/8 is less than 4/8. So our steps here would be to make like denominators and then compare. Whichever one has, since the pieces are now the same size, whichever one has the most pieces is going to be your larger fraction. All right, so cross products. Sometimes it's too close to compare to 0, half, or whole. Sometimes our denominators aren't very friendly. So let's learn how to do cross products. Let's take, for example, 7/8 and 5/6. So they're both pretty close to 1, and my denominators can't be made the same extremely easily. So here's a rule that you need to know. When I multiply across, which is why it's called cross products, and I multiply the diagonal. Well, first of all, when I make those two diagonal lines, you'll see that it's a multiplication sign, which is exactly what we're going to do. So we're going to go ahead and multiply up here. How I think of it is I have an airplane, a really bad looking airplane, taking off, and it's flying through the 8 and through the 5. Then I have another airplane over here, which is taking off up through the 6 and through the 7. So airplanes always have to take off from the ground. So you always start your multiplying up. So 8 times 5, and then I like to put the number 40, since it's an airplane, up here in the cloud. This airplane takes off. 6 times 7 is going to give me 42 up in this cloud. Now whichever fraction has a larger number in the cloud above it is your greater fraction. So because 42 is greater than 40, I know that 7/8 is greater than 5/6. And I would be able to go ahead and write that down. Okay, so again, for cross products, this is really slick. This works with any fraction. You are just going to start down. You're going to multiply up and put your answer up in the cloud. Multiply up this way, put your answer in the cloud, And again, whichever fraction has the larger number above it is your larger fraction. All right, so let's take a look at another strategy. And this is to reduce. A lot of times we might get pretty large numbers like this. And it's hard for us to really tell. But if we simplify both of the fractions, it might become a little bit more apparent. So let's start with this one. The greatest common factor of 24 and 30 would be to divide them both by 6. So 24 divided by 6 is 4, and 30 divided by 6 is 5. All right, so I know that this fraction is 4/5. Now over here we're going to we can divide them both by 4, and I get 3/4. So this isn't super easy, I guess, but if you know your fractions well, you would know that 3/4 is less than 4/5 because we have smaller pieces and more of them. They're each missing one piece, but this one's missing a larger piece because fourths are larger. So we're going to go ahead and say that 4/5 is greater. Let's try another example where maybe they're not quite so close together. How about 10 over 30? And we will compare that to, how about 20 over 40? All right, so greatest common factor is 10. So we're going to divide by 10 is 1, divide by 10 is 3. Over here we're going to divide by 20. So 20 divided by 20 is 1, and 40 divided by 20 is 2. Now we have easier fractions to think about, 1/3 and 1/2. Now I know that if I have a candy bar cut into thirds and I have 1, I can see that that is going to be less than a half. So I know that a third is less than a half, so 1/2 is my greater fraction. So again, sometimes this will help you out. None of these strategies are perfect to use all the time, but if you know your strategies well, then you can determine in each situation which one is going to be the most efficient for you. So here's a sheet that you have. What I would like you to do is think about all those strategies and decide for each one which one might work the best. So I'll do a few. I'll do the first row with you, and then you're going to finish this up on your own. All right, so we have 5/6 and 1/2. Well, 1/2 is 1/2. 5/6 is pretty close to 1, so I know that's greater. Right here we have 5/6 and 9/12. I see that they have denominators that are easy to make the same, so I'm going to change this to 12ths. 6 times 2, so 5 times 2 is 10/12. And then I can see that 10/12 is greater than 9/12, and there I go. All right, we have 2/3 and 5/6. Now, we talked about this in class. Both of them are missing one piece. Well, since thirds are larger pieces than sixths, and it's missing one larger piece, then I know that this is actually going to be smaller than this one right here. I can test that by doing like denominators. Let's change this to 6. Especially works well if the one number goes into the other. So 3 times 2 and 2 times 2 is 4. And sure enough, 4/6 is less than 5/6. Now these two, the denominators is already the same. So having 3 pieces is less than having 7 pieces. Now what I'd like you to do, if you didn't use cross products for your first strategy, which maybe you will for some of them, I want you to go back and check all of your answers on this page with cross products. So here's what that'll look like. I'm going to go back and check my answers. 6 times 1 is 6, so I'm going to write that up here. 2 times 5 is 10. 10 is greater than 6, so I am correct. 5/6 is greater than 1/2, and I can put a star by it. Let's try this one. 6 times 9 is 54. 12 times 5 is 60. Because 60 is greater than 54, 5/6 is also greater than 9/12, so I'm correct. 3 times 5 is 15. 6 times 2 is 12. 12 is less than 15, and 2/3 is less than 5/6. Notice my signs match up here. All right, 9 times 7 is 63. 9 times 3 is 27. 27 is quite a bit less than 63, so 3/9 is less than 7/9. So your directions on this page are to use one of the strategies from our notes, whichever one you think is going to be the easiest in each example, and then I want you to double check all of them using your cross products and then put a star if you are correct. All right, so good luck with this lesson. We will do some more work in class.